So first, let's see the basic ideas behind the limits. In general, limits allow us to determine what values a function is approaching when we use a particular output. If we explain it in analogy, imagine that you are sleeping on a couch and started to dream about cake. This will make you really craving for cake when you wake up. So you decided to go out and grab some cake. In this scene, if we want to describe someone who is going to some places, it would say they are approaching to something. As you keep walking and getting to the location, it is mean that you are getting closer and closer to the location. This scenario is the same thing as we want to do with the function. When we take the limits of the function, we are describing where they are going. For example, the function of x to the power of 2 minus 1 over the x minus 1. In this function, if we try to plug in the x equal 1, the results will be 0 over 0 or undefined. So in this function, we cannot work out directly, but we can see what it should be as it getting closer. In this case, instead of figure out x equal 1 out, we can say that the value of the function might get closer near as x equal 1. When we write the limits of f of x as x approach to a, it is indicate that x is approaching a from both sides. So if we want to be specific about the sides from which the x values approach the values of a, let's have to use the notation, which are the limits of f of x as x approach to a with negative signs on the top corner indicates that the limits from the left side where x is less than a, while the limits of f of x as x approach to a with positive sign on the top corner indicates that the limits from the right, which are x is more than a. Both of these notations are called left-hand and right-hand limits. In order for limits to exist, both the left-hand and right-hand limits must exist and be the same. For example, in this equation, it is the limits of 2x squared plus 5. The behavior of function equals to 2x squared plus 5 near x equal 1 can be determined from a table of the values. To conclude, as we plug in the x value that is nearer to 1 into the function, this will make us getting the values of f of x as shown in the slide, so the answer of this equation will be 7. So if you create the graph of the previous questions, you will notice that the rate point on the graph is equal to 7. Here is the other example with two conditions, where you have to find the limits of f of x as x approach to 3. The first function is 2x plus 3 if x less than or equal to 3, and the second one is 5x plus 1 if x is more than 3. So when we create the table and plug it in the values that is nearer to 3, it should depend on the conditions. As we plug in, the answer will be 9. If the function comes from different sides and includes a break as seen in the picture, this will make the limits does not exist at a. We can't say what the value at a is because there are two competing answers. The first one is 3.8 from the left and 1.3 from the right. But we can use the special signs as positive and negative signs as shown to define one-sided limits, which are the left-hand limits, the negative sign is 3.8, and the right-hand limits, which are the positive sign is 1.3. And this will leave the ordinary limits as does not exist. And these are the techniques for calculating limits, which are dividing out technique and rationalizing technique. This is the questions that indicates the side of values x, so as the limits of f of x as x approach to 4 from the left side equals to the x squared plus 6x plus 8 over x plus 4. If we try to plug in the values of x in, the answer will be undefined. Instead, we'll use dividing out techniques by factorizing the upper equation and cutting down x plus 4, which will remain as x plus 2. From here, we can plug in the values of x, then we will have the answer as 6. Now we are coming to rationalizing technique, so instead of plugging 16 into the equation, we'll multiply the function by its conjugate. Here we can break down the root and then using dividing out technique to cut down x minus 16. This will leave the function as the limits of f of x as x approach to 16 equals to 1 over root x plus 4. Last step is plugging in and then it will leave the answer as 1 over 8.